We'll start now with a standard normal variable. If you're not sure on that, just go back and watch the previous video where we introduced the density function of a standard normal. But what we're going to do now is we're going to consider the square of that variable, or the distribution of x squared, if x is a standard normal. Now before we start, we can do a few things. Well, x can take any real number, so its square can take any non-negative real number. The most likely value, the mode of x, is 0. So if I square it, the mode of x squared should also be at 0. It'll look something like this. So you can think of that almost as half of the bell curve, but it's going to drop away much quicker because when I'm squaring, I'm sort of exaggerating how rapidly that drops off. Now this is itself a standard distribution, and this is defined as a chi-squared variable, specifically a chi-squared variable with 1 degree of freedom. So I'd write this as a chi-squared and then note 1 degree of freedom. So let's actually work out what its density function is. So let's say x is a standard normal. I square it and call x squared equals z, and say therefore z has a chi-squared distribution with 1 degree of freedom. Well, this is the density for a standard normal. This is just the normal density function with mu, the mean set as 0, and the variance sigma squared set as 1. 1 on root 2 pi e to the minus x squared on 2, for x being any real number. Now what I want to do for my change of variable is I want to set z equal to x squared. But if I do that, it's not a one-to-one transformation, because for every x, there's a minus x that'll map to the same z. So it's not a one-to-one transformation. So I've got a nice trick here, which is just in fact to only consider values the positive x, and then I'll get half of the answer, and then I'll double it up to deal with the influence of the negative half that I've ignored in the calculation. So if I do the change of variable here, this is no more than what we'd see if we were doing, for example, an integration by substitutions change, or you can think of this as chain rule in differentiation. So if my change of variable is that z is x squared, then x is the square root of z. And I can take x to be this positive square root of z, because I'm only considering non-negative x. So if I differentiate that to get dx by dz, I get a half of 1 on the square root of z. All I need to do now is substitute in, replacing the x squared in the original density function with the z, and then multiply by this dx by dz. So this gives me the density function of a chi-squared with 1 degree of freedom. You may have seen this before if you've done other statistics subjects, but I think a lot of people use a chi-squared variable without knowing or seeing or understanding that it's just the square of a standard normal.